Calculus Math 11. Dance. Dance. Today, converting quadratic equations from standard form to vertex form by completing the square. Well, as we saw previously, the conversion from vertex form to standard form is really quite easy. And we did that at the start of the previous video by expanding the binomial, multiplying the a value in, and then adding q. And here's a quick example of that. So how do we change from standard form back to vertex form? The answer? By being very, very sneaky. We use a process called completing the square. Do you remember algebra tiles? I know, you hate them. That's fine, but they are really good at demonstrating this concept. Remember, the area of an algebra tile is the name or value of that tile. So this tile, x squared, is x units by x units. Its area is x squared. The x tile is 1 unit across the top by x in height, giving it an area of 1x. And then the unit tile, of course, is 1 by 1, giving it an area of 1 unit. If we want to go negative with these, we can switch them to negative areas inside as well by clicking on them like this. Okay, so let's get the value x squared plus 4x. But what I'd like to do with them right now is to try to arrange all of these tiles into a single square. Well, this almost works, but I'm still missing some squares, some values that would fill in this region right here to complete this as an entire square. So I'm going to go and get those values and add them in here. Of course, if I just add those 4 units in here to make this into a perfect square, I've completely changed the value of what I had here in the first place. So I'm going to balance that off by grabbing 4 more unit tiles and making them all negative. The net value of everything on the screen right now is exactly what it was before, x squared plus 4x. Now I could take these two values here as two separate polynomial statements, x squared plus 4x plus 4 minus 4, and notice the first 3 terms make a perfect square, which I can factor as x plus 2 squared minus 4, meaning that the area of x squared plus 4x is the same as the area of x plus 2 squared minus 4, which is a lovely parabola whose vertex is located at -2, -4. Its minimum area is -4 when x equals -2, and so on. Well, let's try another one now. Y equals 4x squared minus 24x minus 7. As you can see, I've already put the tiles together here, and I've put the -7 off to the side since it's not really part of the square, it's actually taking away from it, and it's just easier for me to try to find what's missing in here anyways in order to complete this square. You can see I have the 4x squared here, I have the -24x broken up into 2 groups of -12x, and what's missing right in here would be 6 by 6, or in other words, a plus 36. And I could go in and add all of those, but before I do that, consider that 4x squared minus 24x has a common factor of 4, which means that I could actually split this one large square into 4 smaller squares, like this. So what I really have is 4 squares which are x minus 3 in dimensions, and then I've got this -7 off on the side. And what's required in each of these squares would actually just be 9 units, 3 by 3. And at this point, though, I've added 4 blocks of 9 squares, which is still 36, I need to undo this then by creating 36 negative squares as well. This means now that I have 4 squares of side length x plus 3, and the negative 7 combines with the negative 36 to give me negative 43. This is a process called completing the square. And although it actually isn't too difficult to do it with the algebra tiles, pulling them out and using physical algebra tiles every time is kind of a pain in the butt. And I'd rather like to get over to an algebraic process for this. And we've got one. There's 5 steps that we can do to complete the square. And here they are. The first step for converting from standard form to vertex form by completing the square is to factor the a value out from both ax squared and bx, but not from the c value. So if we're working with the equation y equals negative 2x squared minus 12x plus 3, I will factor negative 2 out from both negative 2x squared and minus 12x, giving me y equals negative 2 times x squared plus 6x, and I'm leaving the plus 3 out. The second step is to determine what amount needs to be added in order to have a perfect square. The value that needs to be added turns out to be the square of 1/2 of what is now the x coefficient. The x coefficient now is 6, half of that is 3. When we square 3, we get 9. This would need an extra 9 inside of the brackets in order for it to be a perfect square. So I'm going to take that missing amount and I'm going to add it and subtract it inside of the brackets in order to complete the square. So I have x squared plus 6x plus 9 and minus 9, and then plus 3 outside the brackets. The next thing to do is to multiply the subtracted value by the factor a, which is out in front of the brackets, in order to remove it from the brackets. I want that negative 9 to come out of these brackets so that all that's left in there is the perfect square trinomial. So to take the negative 9 out, I multiply it by negative 2. And of course, negative 2 times negative 9 gives me positive 18. Step 5, factor the perfect square and simplify the constant terms that are outside of the brackets, giving me negative 2 times x plus 3 all squared plus 21. How did I get these? Well, factoring a perfect square should be really easy. You start off by taking the square root of x squared, which is x, the square root of 9, which is 3, and we will use whatever sign is in the middle. And don't forget to write squared on the outside as well. Step 6. There is no step 6. You're done. You have the quadratic function now in its vertex form. Congratulations! Let's try another one following the 5 steps from up above. Let's start by factoring out the value of 3 from the first 2 terms. This gives me 3 times x squared minus 3x, and I leave the plus 4 outside. I've got 2 blank spaces here because I have to determine what value do I need to add into here to complete the square. What we said to do is to take 1/2 of the current x coefficient and square that amount. Half of negative 3 is probably the easiest dealt with as negative 3 over 2. And so I've got negative 3 over 2 squared, and I'm going to add that amount and subtract that amount. Of course, negative 3 over 2 squared is just 9 over 4. And when I multiply the negative term, negative 9 over 4 times 3, that gives me negative 27 over 4, which I can take outside of the brackets like this. Now that completing the square is done, we need to factor, and we need to simplify the terms outside the brackets. This factors as x minus 3 over 2 all squared, and 16 over 4 minus 27 over 4 simply becomes 11 over 4. Let's try another one here that's a little bit nastier and has some fractions in it right off the beginning. I need to start by factoring out the negative 2/5, which comes easily enough off of the x squared, but maybe is a little tricky for some of you guys when we take it off of the value of positive 4. Remember, when we factor it out, we're dividing it out, and so all we have is 4 divided by negative 2/5, which is simply equal to negative 10. Now we can go ahead and complete the square, taking half of the value of negative 10, that's negative 5, and negative 5 squared is 25, so I'm going to add and subtract values of 25 right in here. I want to take the negative 25 and get it out of this bracket, and the way that I get it out is to multiply it by negative 2/5, and again this will actually multiply quite nicely. Negative 2/5 times negative 25 works out to be positive 10. And now the final stage, factoring this perfect square and simplifying the outer terms. The square root of x squared again is x, the square root of 25 is 5. I take the sign from the middle, and negative 7 plus 10 is 3. So we have y equals negative 2/5 x minus 5 squared plus 3. And now on to an application question. Eric, the used BlackBerry salesman, wants to increase his sales revenue. He currently sells phones for $12 each and sells 500 phones each month. But his research indicates that for every $1 price increase, he will sell 25 fewer smartphones. Write a quadratic function to model this situation and explain everything that you can from that model. The first question, what is revenue? Well, revenue is the total amount of income generated. Revenue is the number of items sold times the price per item. And we can say that the number sold is 500 minus 25 for every $1 price increase. And his price per item is 12 plus, well, an as yet unspecified amount. But we know that his intent is to raise the price in $1 increments. So let's suppose that he raises the price n times. This will make the number sold 500 minus 25n and the price 12 plus n, and therefore his revenue is 500 minus 25n times 12 plus n. Revenue is a function of n, the number of $1 price increases. If we expand this and convert it into Vertex form by completing the square, we can get some really useful information out of this equation. So we'll start by using the distributive property to expand this binomial multiplication, and then rearrange the terms. Now complete the square. Factor out the negative 25 and determine what amount needs to be added and subtracted. Take the negative 16, bring it out of the brackets by multiplying it by negative 25, getting positive 400. Finally, factoring, we get r of n is equal to negative 25 times n minus 4 squared plus 6,400. It tells us that the revenue function would graph as a parabola that opens downwards with its vertex at 4, 6,400. And since it opens downwards, we know that it has a maximum value for r of 6,400 when n equals 4. Therefore, the maximum revenue that Eric can earn from his used smartphone business is $6,400 per month. In order to achieve this level of revenue, n must equal 4. N is not the price is 12 plus n, so the price is actually $16. How many sales will he make? He's going to be selling 400 phones per month at $16 per phone, making his revenue $6,400. And now here's two for you. First one, convert each of the following into Vertex form by completing the square. And the second one, Will selling Van Can t-shirts to unsuspecting tourists near the Jackpool Plaza. What price should he be selling at in order to maximize his revenue? Well, that's all for today. Thanks for dropping in. I hope you had a good time. I know I did. Until next time, keep your pencils sharp, your squares completed, and I'll see you in class.